Okay, these are homework questions from the first section of chapter 1. All right, first 41. This is a cubic, and so you guys might remember that cubics look like this, and this one's been shifted 3 units up. Okay, we're going to learn about shifting functions. So right away, I look at this and I know what it looks like. It looks like that. Hopefully, you guys get to that point too. But for now, if you don't, if you want to figure out, like for example, the intercepts, I know if I plug in 0 for x, that's going to give me the y-intercept. And it makes sense because anywhere where a function crosses the y-axis, x is 0. So in this case, when I plug in 0 for x, I get 3 for y. So I know that 1, 2, 3, the y-intercept is at 0, 3. So anytime you want to find the y-intercept, plug in 0 for x. Makes sense because when x is 0, that's where it hits the y-axis. This is the point 0, 3. Now if I plug in 0 for y, that gives me the x-intercept. So let's try to plug in 0 for y and see once if we get any zeros. I'm going to subtract 3 from both sides. And this gives me x cubed equals negative 3. Cube root both sides, you get x equals negative cube root of 3. Okay? Which cube root of 3, I don't know what that is. I can do it on my calculator, some decimal.
Where did the negative go?
When I take the cube root of both these sides, I didn't show my work very well. This is x cubed. When I take the cube root of both these, the cube root of negative 3 gives you on your calculator negative 1.44-ish. So what that means is about here is the x-intercept. So this function, looks like this. Oh, that's pretty bad, actually. It looks more like that. Anyways, it does want us to sketch it, but first it wanted us to do the test to see if this function is symmetrical about the x-axis, the y-axis, or the origin. Okay. So the test to see if it's symmetrical about I know it's not symmetrical about the x-axis, but the test would be to replace y with negative y and see if you get the same function. I don't, because if I replace y with negative y, I get this. And then if I solve for y by multiplying both sides by negative 1, I get this. This is obviously a different function. Okay, this one opens like this and is shifted 3 units down, so it actually is shifted down, but it looks like that. Okay, so that's different. That doesn't work, so it's not symmetrical about the x-axis. I know it's not symmetrical about the y-axis either, but to test that, let's see. If this was the point xy, about the y-axis, this would be negative x, y. So I should be able to replace x with a negative x and see if it's the same function. This gives me y equals negative x cubed plus 3, which this is not the same function either. The other thing I want to do is I want to test to see if it's symmetrical about the origin. So I'm going to replace x with negative x and y with negative y. So I'm going to stick those in for x and y. So I'm going to have negative y equals negative x cubed plus 3. Now let's see if that gives me the same equation. This would be negative y equals negative x cubed. I can pull out that negative because, negative 1 cubed is still negative 1. All right, now I'm going to multiply through by a negative. And this gives me y equals x cubed minus 3. This is not the same as this. Therefore, it's not symmetric it's not rotationally symmetric. Okay? So the 3 tests, you might be kind of confused about how to do them and how to remember what to test. Well, it's simple. If this is the point xy, if the function is symmetrical about the x-axis, then the point negative xy would also be in the function. So to test if it's symmetrical about the x-axis, what you can do is stick in the negative x. I'm sorry, I did this wrong. This is x negative y. So to test if it's symmetrical about the x-axis, stick in negative y in for y into the function and see if it gives you the same function. Okay? Let me explain that again. Here's the point xy. If the function, whatever function this point is on, is symmetrical about the x-axis, like this, then the point x negative y is also in the function. So replace y with negative y, and then simplify and see if you get the same function back. Okay? Let me give you an example of one that works then. X equals y squared. I know this isn't a function, this is a relation. I know it looks like this. That's symmetric about the x-axis. So if I stick in negative y in for y, I get negative y squared equals x. When I simplify it, it turns into y squared equals x, which is the same relation. So you can these tests will tell you if it's symmetric about the x-axis, y-axis, or origin. So if you want to try y-axis, if it's symmetric about the y-axis, then this point, negative xy, will be on there. So stick in negative x and see once if you get the same function. Here's an example of that. Y equals x squared is symmetric about, it's a parabola, right? So I know this should work. Well, let's try it. I should be able to stick in negative x in for x, and I should get out the same function. Let's try it. When you square the negative sign, it goes away, and you get back the same function. Therefore, the test would be to stick in negative x in for x and see if you get the same function. So let's try another one. Let's try 42. We know what this function looks like. I mean, hopefully you guys will too. It's a cubic function that's shifted down 1 unit, so it looks like this. Okay. Obviously, this is not symmetric about the x-axis, the y-axis, or the origin. So I know that none of these tests are going to work. But we still should do them. This one wanted the x and y intercepts too, so let me do those first. The the y-intercept would be when you stick in 0 for x, which gives you negative 1 for y. The x-intercept is what you get when you stick in 0 for y. So I'm going to add 1 to both sides, and then cube root both sides, so that's 1. When I cube root 1, you get 1 back. Alright, so the x-intercept is at 1, 0, the y-intercept's at 0, negative 1. Now, symmetry. Let's test for symmetry. Alright, the x-axis test is if it's symmetric about the x-axis, then the point xy and x negative y are both on there. So I'm going to replace y with negative y and see if I get the same function. It would be negative y equals x cubed minus 1. Multiply both sides by negative 1 and you get this. Which that is not the same as that. They're not the same. So therefore, it does not have x symmetry. If I want to show all my work, I would say no x-axis symmetry. Okay. Now I'll test for the y-axis. With the y-axis, when I flip it over, this is going to be negative xy is going to be on there. So I'm going to plug in negative x for x. Okay. Now when I simplify this, that negative sign stays there because negative 1 cubed is still negative 1. So therefore, this function is not the same as the original. So it has no y-axis symmetry. Okay. Now let's try what the book calls origin symmetry or rotational symmetry. To do that, I'm going to replace x with negative x and y with negative y. Okay. Now I'm going to simplify to see if I get the same function. So I get negative y equals negative x cubed minus 1. When I multiply through by a negative 1, I get x cubed plus 1. It's close to the same function, but there's a different sign there. So this one's shifted up instead of down. So therefore, it has no origin symmetry either. Okay? So no symmetry. I know it's a lot of work to show, but those are the tests that you can do, the algebraic tests, without actually having a grapher in your hand. So that might come in handy on a no calculator portion of a quiz or a test. If I asked you if it has x-axis symmetry and you're not sure, you could run one of these tests. Okay? So this is 51. We just want to graph this with our calculator, which hopefully you guys know how to do. If not, all you do is take your calculator, go to y equals, and insert in the equation x squared minus 4x plus 3. And just hit graph. Okay, it's a parabola. This one's been shifted over and the vertex is moved as well. But I usually do a standard window, so zoom standard, which I believe is zoom 6. But yeah, it's just a parabola that opens up, and your calculator can give you an idea what it looks like right away. Okay, this is number 73. It says find the center radius of the circle and sketch its graph. Okay, so I know our equation for a circle is x minus h squared plus y minus k squared equals r squared. So I know that my h is 1/2, right? Just copying from here, and my k is 1/2. So the center of the circle is at 1/2, which is here. All right. Now the radius is, here's r squared, clearly. So I'm going to square root, if I have r squared and I know it's equal to 9/4, I'm just going to square root both sides to get what the radius is, which is 3/2, so 1.5. So I'm going to go out 1/2 and then 1 to here, and that's my circle. So I'm going to go out 1/2 and then a full another unit to here, go down 1/2 and then a full another unit to here, so there's a circle with a radius of 1/2. And I'm not very good at drawing circles, but that's my best attempt. I'm supposed to go through that point. So this is a circle centered at 1/2, 1/2, and it has a radius of 1.5. The calculator will obviously do this for you as well if you go to apps, conics. And click on circle. This form, 0.5 was 1/2, 1/2 was our center, and the radius was 1.5 or 3/2. And if you hit graph, this is going to be obviously a little bit better of a sketch. Okay. Okay, here's 65. It wants us to write standard form of equation of a circle with this center, and this is one of the points. So the solution point is just one of the points on the circle. All right, so we know that standard form for a circle is x minus h squared plus y minus k squared equals r squared. We know the center is at -1, 2, so it's x minus h is -1. K is 2. Now we need to find the radius, and obviously the way to find the radius is to find the distance between the center and one of the points on the circle. So if you quickly graph this, 0, 0 is one of the points on the circle, and the center is at -1, 2 here. So the circle looks something like that, and we want to find the distance between those 2 points. We could make a little triangle right there. If you look at this little triangle, this is 1, this is 2, and you could do the Pythagorean theorem, or the distance formula between these 2 points. Doesn't matter. Either way, you'll get the radius, which is right here. So it's 1 squared plus 2 squared equals c squared for Pythagorean theorem. A squared plus b squared equals c squared. This would be 5 equals r squared. So r is the square root of 5. So I have the square root of 5 for r, and I need to square that for the equation for a circle. So to simplify, I'm going to have x plus 1 squared plus y minus 2 squared equals 5. Let's just double check this by plugging this into the conics app again. -1, 2 is the center, and the radius is square root of 5. Hit enter, and then just take a look at the graph. And it does match the graph that we had here. The center is at the right spot, right radius. So this is the right equation. There is different ways to do this. Someone just pointed out that another way to do this problem, if you don't know what r is here, what you can do is plug in one point for x and y and solve for r. We know that one of the points was 0, 0 on the graph, so plug that in and you'll actually find the radius, and you'll find the radius is 5. That will work as well. Let me just plug in 0, 0. If I plug in 0, 0, I get 1 squared plus -2 squared equals r squared. This is 1 plus 4 equals r squared. It's 5 equals r squared. Square root both sides, and you get the same thing. R equals 5. So it does work. All right, I hope this helps.